In this question, we are told that x lies between 2 and 6, and we are required to calculate the probability that we'll define this as the least integer greater than x square is equal to the square of the least integer of x. First, let us try to understand what does this function represent. It represents the least integer which is greater than or equal to x. So just to give you an example, what is the value of least integer greater than or equal to 2.5? This will equal 3. Similarly, what is the least integer greater than or equal to 3.1? This will equal 4. So in this particular case, x will vary from 2 to 6, and so the least integer which is greater than or equal to x can be either 2 or 3 or 4 or 5 or 6. The least integer greater than or equal to x will become equal to 2 if and only if x is equal to 2 in this particular interval. Because we know that x is always greater than or equal to 2. So if x is not equal to 2, the least integer which is greater than or equal to x will be greater than 2. If the least integer of x, least integer greater than or equal to x, if that is equal to 3, the value of x has to vary from 2 to 3. Similarly, the least integer greater than or equal to x, if it is equal to 4, the value of x will vary from 3 to 4. For example, the least, as we have discussed, the least integer greater than or equal to 3.1 is equal to 4. And what is the value of x for which the least integer greater than or equal to x is equal to 5? This would imply that x will vary from 4 to 5. And for the last one, the least integer greater than or equal to x will be equal to 6 if the value of x varies from 5 to 6. Let us look at each of these cases. The first case we can ignore because it is just 1 point, x is equal to 2. So when you are trying to calculate the probability, it will not really affect it. Probability is affected by a range of values of x, not by a single point of x. So let us first consider and try to calculate the values of x for which the least integer greater than or equal to x is equal to 3, and therefore this would imply that the square of the least integer greater than or equal to x will be equal to 9. So for what values of x is the square of the least integer greater than or equal to x, which will equal 9, equal to the least integer greater than or equal to x square? This has to equal 9. So for what values of x is x square, the least integer greater than or equal to that, is equal to the square of the least integer greater than or equal to x, and this also equals 9. We'll first calculate this. We'll calculate the range of values for which this is true. Then we'll calculate the range of values for which this will equal 16. Then we'll calculate the range of values for which this will equal 25. And finally, we'll calculate the range of values for which this will equal 36. In the first case, we know that for the least integer square to equal 9, the least integer has to equal 3. So x has to belong between 2 and 3. For what values of x is the square of the same least integer function applied to the square of x equal to 9? This would imply that x square has to vary between 8 and 9. Or this would imply that x has to vary between square root of 8 and 3. So whenever x varies between square root of 8 and 3, x square will vary between 8 and 9. So the least integer which is greater than x square will be equal to 9. And for all of this, because the points square root of 8 and 3, all of them lie between 2 and 3. For all of them, the least integer greater than or equal to x is equal to 3. And so the square of that number will equal 9. Similarly, if you are looking at the second instance, here if x lies between 3 and 4, the least integer greater than or equal to x is equal to 4. So the square of this least integer greater than or equal to x whole square will equal 16. Now in this particular case, if you want the square of x square's least integer greater than or equal to x square to equal 16, x square has to lie between 15 and 16, or the value of x has to lie between square root of 15 and 4. Similarly, for the third case where you want the both of this x square and x square, the least integer greater than or equal to both of them, if you want both of them to equal 25, the value of x has to lie between square root of 24 and 5. and square root of 25, which is equal to 5. And in the last case, when you want the least integer greater than or equal to x square and the square of the least integer greater than or equal to x, if you want both of them to equal 36, the value of x has to lie between square root of 35 and 6. So what is the range that x can take between 2 and 6 for which this expression holds true? So x has to either lie between square root of 8 and 3, in which case both of them will equal 9, or x has to lie between square root of 15 and 4, in which case both of them will equal 16, or it has to lie between square root of 24 and 5, in which case both of them will equal 25, or it has to lie between square root of 35 and 6, in which case both of them are going to equal 36. So the total range that x can take will be, if you are calculating the length, it will be 3 minus square root of 8 plus 4 minus square root of 15 plus 5 minus square root of 24 plus 6 minus square root of 35. This is the length of the range that x can take for which the given expression will be true. And what is the length of all the ranges that x can take? It is equal to 4, because x can vary between 2 and 6 and it varies uniformly. So the required probability is all of this divided by 4. This will come to approximately equal to 0.48 divided by 4, which is equal to 0.12.